So 1.5 part 2. So we're going to continue with our imaginary numbers that we talked about in part 1. If you weren't here Friday and haven't watched the video on part 1, make sure you watch the video, but we'll kind of talk about the same stuff today. So looking at number 1, if we have a negative under the square root, we want to take those out and turn them into i's. That's where i's come from, is a negative under a square root. So to simplify it, you want to take the negatives out, turn it into an I. Now, what's the square root of 25? 5. So this would be 5i. And then what's the square root of 36? 6. So this would be 6i. We talked about on Friday how you can only add a real number with a real number and an imaginary number with an imaginary number. So these are like terms, so we can add them together. So our answer would be 11i. All right, let's look at number 2. So first thing you want to do is take the negatives out, turn them into i's. Then we need to simplify our radical. So the square root of 27, what are two factors of 27? 3 and 9. And two factors of 9? 3 and 3. So we want to circle any pairs that we have. So I have a pair of 3's. So 3i is going to come to the outside because we took that I out in the beginning. What stays on the inside? 3. This 3 did not get circled, so the 3 has to stay on the inside. Let's do the same thing with the next one. We took out the I. What are two factors of 48? Awesome. 4 and 12 also works. I picked 8 and 6 first, so we'll start with these two. But if you want to do 4 and 12, that works too. What are two factors of 8? 4 and 2. And two factors of 4? 2 and 2. And two factors of 6? 3 and 2. There's two pairs of 2's. Perfect. So if we already have a negative 3 on the outside, what do we do with the two pairs of 2's that we're taking out with it? We multiply them. So what's 3 times 2 times 2? Awesome. So this would be negative 12i, because we also had the I that we took out. Because whenever it comes to the outside, if we already have a number on the outside, we have negative 3i times 2 times 2. What stays on the inside? Awesome. 3 stays on the inside. So we have negative 12i square root of 3. Now let's do the same thing with the last one. What are two factors of 12? 6 and 2. And two factors of 6? 3 and 2. So circle any pairs. We have a pair of 2's. What's going to come to the outside? 2. What stays on the inside? 3. Perfect. Now, all 3 of these have the same square root, so you could add them together, but 2 of them have i's. So remember, you can only add a real number with a real number, an imaginary number with an imaginary number. So I can only add my imaginary numbers together. So 2 square root 3 can't get combined with those. So I'm going to put that one first since it's a real number. There's no imaginary there. So 2 square root 3. Then the other 2, I'm going to add these two together. What's 3i square root 3 minus 12i square root 3? Awesome. Negative 9i square root 3. Perfect. You just combine the numbers together. 3 minus 12 is negative 9. So just like we talked about in part 1, the real part has to come first. Imaginary part second.
It has to go second, or?
Yes. Let's do the same thing with number 3. So I'm going to take the negatives out, turn them into i's. Now let's simplify each of our radicals. What are two factors of 50? 5 and 10. And two factors of 10? 5 and 2. So circle any pairs that we have. What's going to come to the outside? The 5. What else comes to the outside? I. Perfect. What stays on the inside? 2. Awesome. So we have 5i square root 2. Let's do the same thing with the next one. What are 2 factors of 45? 9 and 5. And 2 factors of 9? 3 and 3. So I circle any pairs that we have. So I have a pair of 3s. 3 comes to the outside, but what do we do with the 6 that's already on the outside? Add it. No, not adding. Multiply. We multiply it. So what's 6 times 3? Awesome. 18. What else comes to the outside? I. What stays on the inside? 5. So 18i square root 5 is what the middle one turns into. Let's do the last one. What are 2 factors of 75? 25 and 3. Perfect. 2 factors of 25? 5 and 5. So we have a pair of 5s. So when we take that 5 to the outside, what happens to the number that's already out there? We multiply it. So negative 3 times 5 would be negative 15. What else comes to the outside? The I. What stays on the inside? The 3. So negative 15i square root 3. Now all 3 of these have different radicals. Can we still add them together? No. So when they have different radicals, you can't combine them. All 3 of these have i's. So do we have a real part? No. So they're all imaginary. So this would be our answer. Can't add them together. We just simplified as much as we could. Next, we're going to talk about dividing with complex numbers. So whenever we have an I in our denominator, so like we have here, we want to multiply the numerator and the denominator by the complex conjugate of the denominator. So the complex conjugate is the same numbers, but the sign in the middle changes. So if here it has C and D as the numbers. It doesn't matter what they are. It's just the sign in the middle that changes. So the complex conjugate would be C minus DI. Whatever we multiply to the bottom, you also have to multiply to the top. So if I had, let's say, 2 minus 4i, what's the complex conjugate of this? Awesome, 2 plus 4i. Perfect. Just the sign in the middle changes. What if I had negative 1 plus 3i? What's the complex conjugate of this?
1 minus 3i.
So it'd still be negative 1 minus 3i. It's just the sign in the middle that changes. So let's look at example A on the next page. So we want to multiply it by the conjugate of the denominator. So 1 minus 2i, what's the conjugate here? 1 plus 2i. Awesome. Whatever we multiply to the bottom, we also have to multiply to the top. So 1 plus 2i gets multiplied to the top too. Up top, you want to FOIL. So you have to FOIL these out up top. We'll start with foiling first. So 3 times 1 would be 3. 3 times 2i is 6i. 5i times 1 is 5i. And then 5i times 2i would be 10i squared. So we FOILed out the top. We got this. Let's simplify a little bit more. Does anybody remember from Friday what I squared changes to? Negative 1. So what's negative 1 times 10? Negative 10. Perfect. So this changes to be negative 10. Anytime you have an I squared, you want to change it to be negative 1. So then we can combine the real parts together. What's 3 minus 10? Negative 7, perfect. And then the imaginary parts, 6i plus 5i. Perfect, it'd be 11i. So we have negative 7 plus 11i. So this is our numerator. Let's do the same thing for the denominator. You can FOIL out the denominator. It will totally work with foiling. But we actually have a shortcut that we can do when we multiply with conjugates. So when we multiply with conjugates, it's the first number squared minus the second number squared. So this is our conjugate shortcut. Now this only works when you multiply with conjugates. So one of them is going to have a plus and one's going to have a minus. So our first term is 1 squared minus the second term is 2i squared. So we have 1 squared would just be 1. For 2i squared, we have to be careful. We have to square the 2 and square the I. So this would be minus 4i squared. And what does I squared change to? Negative 1. So what's negative 1 times negative 4? Positive 4. So it just changes to a plus. So we have 1 plus 4 would be what? 5. So our denominator would be 5. So this would be our answer. So negative 7 plus 11i over 5. On WebAssign, so when you type your answer into WebAssign, it wants you to separate them. So it'd be negative 7 over 5 plus 11i over 5. You don't have to separate it on a test or quiz. You can leave it all together, but WebAssign is going to make you separate it. If you ever have a question on how to type your answer into WebAssign, you could always try another. See how it wants the answer. So what's the conjugate of 4i? Perfect, negative 4i. So if I multiply the bottom by negative 4i, I also have to multiply the top by negative 4i. So let's multiply the top first. Up top, we just have to distribute. So negative 4i times 7 would be negative 28i. And 3i times negative 4i would be negative 12i squared. What does I squared change to? Negative 1, which makes it what? Positive 12. Could I leave the answer as negative 28i plus 12 up top? Why not? Why could we not put the I first? Because it's imaginary. The real part has to go first. So 12 minus 28i. That's what we got up top. Now let's try the bottom. What's 4i times negative 4i? Negative 16i squared. And what does the I squared change to? Negative 1, which makes it positive 16. So we have 16 in the bottom. Now you can simplify only if all three of your whole numbers are divisible by the same thing. Do we have a common factor for all three of our whole numbers here? 4. We can divide them all by 4. Perfect. So divide by 4, divide by 4, divide by 4. So we get 3 minus 7i over 4. So this would be our answer. Now remember, on WebAssign, it's going to want you to separate it. So it'd be 3 over 4 minus 7i over 4. So for 40, what's the conjugate of our denominator? Perfect. 5 minus 8i. So whatever we multiply to the bottom, we also have to multiply to the top. So up top, we just distribute. We get 45 minus 72i. On the bottom, you can FOIL if you want, or you could use your conjugate shortcut. So our conjugate shortcut is a squared minus b squared. So our a would be 5 squared, and our b is 8i squared. So minus 8i squared. Now be careful here. You have to square the 8 and square the I. What's 5 squared? 25 minus, what's 8 squared? So 64I squared. What does I squared change to be? -1. So -1 times -64? Positive 64. So we have 25 plus 64 would be 89. Now, do we have any common factors between 45, 72, and 89? Nope. So this would be our answer. So remember, on WebAssign, it wants you to separate 45 over 89 minus 72I over 89. So with 41, what should we do? Perfect. We want to multiply by the conjugate of the denominator, so -2 minus I. Awesome. The first term stays the same. It doesn't matter if it's positive or negative. It stays the same. Just the sign in the middle changes. So we have to multiply that same thing to the top too. So -2 minus I. Up top, we want to FOIL. So -7 times -2 would be 14. -7 times -I would be plus 7I. -6I times -2 would be plus 12I. And -6I times -I would be plus 6I squared. What should we do next? Let's simplify the top. How could we simplify? We could add the i's together. 7I plus 12I would be 19I. What else could we do?
Change the I squared to -.
Perfect. Change the I squared to be -1. So -1 times 6 is -6. So we have 14 times -6, or sorry, 14 minus 6 would be what? What's 14 minus 6? 8. Awesome. So notice how I put the 8 before the 19I, because the real part needs to go first. So always put the real number before the imaginary one. Any questions with the top part? All right, let's do the bottom. So at the bottom, you can FOIL. Foiling works, or you could use your conjugate shortcut, a squared minus b squared. Always minus in the middle. So -2 minus I squared. -2 squared minus I squared. What's -2 squared? 4. What is I squared? -1. So what does minus -1 change to be? Plus 1. Perfect. So 4 plus 1 would be 5. So this would be our answer. On WebAssign, it wants you to separate it. So 8 over 5 plus 19I over 5.